Now, I want to believe that you're able to see me. This is Thaddeus Mbaluka, the Ocean of Chemistry. I'm joined by Mr. Mbuguswa, the Boiling Ocean. So the entire Yoruba Command Center is around, and we are going to dispense wisdom dropwise until in excess, until all the confusion dissolves to form a colorless solution. So just welcome to today's session. We are looking at the final preparation of the National Chemistry KCSE Preparation for the 2024 candidates. We are looking at the revision strategies, what you normally use to be able to get that. And I don't know whether watu wananipata kweli. Are you able to hear me?
Yes.
Good. Okay.
Yes.
I can see you you are nodding your ear sagaciously, ready to get wisdom from the UPA Command Center. So we have been waiting for you. As usual, every year I normally do the State of the Nation address concerning the preparation for KCSE. We are now at 230 students, and then we can be able to continue from there. So as I said, this is the UPA Command Center, whereby all this the wisdom trickle down. So we are here to answer your questions.
Your voice.
I'm muted. Oh yeah. Let me see. No, I'm not muted.
It's clear.
So we are clear. So I've said all the teachers will be in maintaining silence. So far, so good. We're doing very well. Mr. Mbuguswa, you can greet the students.
Now, you students.
You're fine, thank you.
Yeah, fine.
Yeah, welcome to the
We're good.
discuss whatever you have prepared for this chemistry.
Okay, get ready. So we are here with you, and we'll be able to you'll be able to answer your questions. As I said, we are here to make sure that we'll be able to disseminate any information that is useful to you. Drop until in excess until the confusion dissolves to form a colorless solution. We are here, Mr. Mbaluka, the Ocean of Chemistry himself, and be ready to navigate through the deep waters of chemistry. Welcome. So the reference point today, we are unmasking, unpacking, unwrapping, unlocking, delving deep, illuminating, focusing on the spotlight zones, learner challenges, emerging assessment issues with the view to demystify the secret of passing chemistry. So in a nutshell, or rather in a summary of that, we're simply trying to simplify any issue that you have concerning chemistry. That's all that is needed. So wherever you're waiting for an exam, you focus on 3 main areas, and that is what is tested, how it is tested, and what are the expectations of the examiner. So it doesn't matter which subject, but you need to know what is tested. I want to believe most of you here, you're a candidate. And if you're a candidate, there is no way now you're going to be spending time learning about apparatus, how to draw a burette, how to draw a pipette, how to learn about, rather memorize the 21 rules of the lab. Those are nonsenses. Those are not things that are going to be tested now. So you need to understand what the examiner is looking for. You also need to know how it is tested. So that you know, like, for example, when you're learning about the simple classification of substances, although in Form 1, you are told to describe how to separate common table salt and sand. When it comes to the KCSE, they are likely now to bring about the concept of salt. That's whereby by Form 2, you'll have learned the insoluble and soluble salt. So instead of the normal question that you're given in Form 2, in Form 1 of how to separate sand and common salt, you'll now be taught how to separate sodium sulfate and lead sulfate. And maybe something like iodine combined together. So in those kind of scenarios, you need to know how the exam can be improved until you are able to get those kind of things. Let's look at now the chemistry exam. The chemistry exam comprises of 3 papers as shown below. I'll not waste a lot of time. So nikifika hapa sasa tumefika zile mahali za kupiga screenshots. Kama hujapiga screenshots, unainua mkono, unaangalia, and those teachers who are here, Enoch.
Yes, sir.
Yeah, you need to also have some teachers looking in the YouTube if there are some questions in the student, the YouTube, but also because we still have space here, those students who are following us through the YouTube, give them the meeting ID and the password so that instead of following via YouTube, they can simply join us here until the Zoom is full with 1,000. This one is a super Zoom that I have bought even large meeting, so we can accommodate up to 1,000. So I advise those students at the YouTube to join us via Zoom and also follow up if there's any questions in the comment section. Those following us live through the Top Notch Online TV, you can be able to write your question in the comment section. The teachers present here will pick that question, bring it here, and will be able to respond accordingly. So let's look at the chemistry exam very quickly. The chemistry exam will start with paper 1 as only 21 questions set from all the 24 topics. The chemistry has 24 topics. The chemistry syllabus has 24 topics. And having 24 topics, we are going to have 27 questions. So for those students who will start disturbing their teachers, mwalimu unaona nini italetwa, give us the prediction for paper 1. Can you be normal? Can you get the real? The prediction for paper 1 is all the topics they are going to feature, right from introduction to chemistry mpaka radioactivity. So hapo inategemea wewe kuelewa topic zote. I'll advise you. If you are a poor conductor of a subject called chemistry, if you find now you are still weak, you are still getting 10 and a half paper 1, 19 and a half paper 2, then I'll tell you the trick, what you need to do. For those who are bright, I'll tell you also what to do. The revision strategy will apply for all of them. Paper 2. So paper 1, maswali zimekuwa tukienda from 27 to around 32 questions, but nowadays the paper 1 is about to have 27 questions. So by knowing that, there are topics that will be repeated. You're going to have more than one question in that topic. Example of that particular topic is the mole. Another topic that you're going to have more than 2 questions is the thought. So we're likely going to find, you may find 2 questions on thought, because a question on thought can be on separation, can also be on preparation, can also be on even the physical properties of thought. You know, even when a question, you know, they synchronize. You know, we also have what we call mixed concepts. If somebody tells you 3.31 grams of lead were heated in a crucible until there was no further change, then they tell you calculate the mass of calculate the total volume of the gases that are produced. First of all, the concept of heating lead nitrate, for you to answer that question, you need to have the knowledge of thought to know when you heat lead nitrate, what you get. Then from there, now you invoke the mole concept, the arithmetic part of it. So you need to have a look at that. So topic zote zitakuwa pale. Kuna ka topic wa sometimes kana miss kanaitanga introduction to chemistry. And in the introduction to chemistry, we only focus on bath and burner and flames. Ukiangalia hata last year when alikuwa anasema the process of heating a solid using a bath and burner, we are still focusing on the bath and burner. That is mostly where you're going to find those kind of questions. So you need to know, don't waste time unasoma usiku mpaka unatoa makamasi ukisoma mambo the rules of the lab. Don't smoke, don't heat, draw burette. You'll never see questions on draw burette, draw a conical flat. And do you know the reason why? Because we teach you the purpose operators so that you can know how to manipulate them, how to use them. And that concept of utilization, use of apparatus, and also the manipulation of apparatus is tested under practicals, because under practicals, they give you the apparatus. You are carrying out practicals. That's why you're not going to find most questions on that. Even with the issues of the rules of the lab, those ones, we also do it. when you talk about you prepare this gas, what precaution, when you need to do it in a fume chamber and all those kind of things. Then paper two, content, I'll allow Mr. Mbuguswa to take it through because in fact is an examiner in paper two.
Yeah, so good evening. Yeah, so we are still illustrating about what is tested in this examination. You've been told that there are 3 examination papers, that's paper 1, paper 2, paper 3. You're told that the paper 1 has at least the 27 questions, and each of the questions must be set at least from each and every topic, from the first one to the next one. Now, when it comes to paper 2, we have 7 questions, and it is not predictable that which one can come, but at least these are most of the topics that can be tested in paper 2. One of them is called the periodicity. Part of the periodicity will be tested in paper 1, but majority of the periodicity actually is in paper 2. And in this periodicity, it does not mean that you expect to see a periodic table. You can have so many tables that are tested on this. You can have a periodic table. You can have one that has atomic and ionic radius. You also have the table for bonding. But all of them, they ensure that at least 5 topics are usually tested under periodicity. Then the next one is called the organic chemistry, which must always be a must. And this organic chemistry, because there is organic 1 and organic 2, organic 1 was taught in Form 3, the organic 4 was taught in Form 4. But now, how do we harmonize all these concepts in organic chemistry? Much of it comes in the exam in form of what we call a flowchart. So as you endeavor to prepare for this particular exam, let us master on how to interpret the flowcharts that can be tested on the organic chemistry. Then the next one is about the physical processes, where under the physical processes, you may have the electrochemistry. Now, one of the things that we never miss in the exam is about electrochemistry. And the reason why it cannot miss in paper 2 is because electrochemistry is not being tested under the practical. It cannot become in paper 3. So it must always be there in paper 2. Quite a number, around 13 marks or so, which tests on enthalpy change, volumetric, those cells, and up to the Faradays comes on that. Then the next one is also called the energy changes, which is combined together with what we call the equilibrium. This one can come in the exam. It can be either a graph, or they may also draw for you a graph where you'll be asked to do what you call the interpretation. Another one is called the industrial chemistry, where industrial chemistry have around 9 processes that are tested in chemistry. And one is that you never miss a question on the industrial chemistry. So as we continue to discuss today, we also need to know which are some of these industrial processes. And these industrial processes, there is a way they are organized whenever we are doing the discussion. We have the fractional distillation of liquefied air, the Haber process, the Oswald process, the Solvay process, the KCSE process, we have crush process, etc., up to metals.
Yes, Mwalimu, before you continue, there might be some students who are wondering what is this animal called KCSE process. So you can tell them the KCSE is the manufacture of what? Now,
KCSE is a process that is stored under electrochemistry, and it deals with the manufacture of 3 substances. One is sodium hydroxide, another one is called chlorine, and the other one is called the hydrogen. And whenever it comes in the exam, it comes with 3 cells. That is the diaphragm cell, the membrane cell, and the mercury cathode cell. And some of the terms that you are mentioning today, you may not be able to see them in the textbooks. But nowadays, those are the ones that are being used to survey all these processes. Just like whenever we are doing about the extraction of sodium, we talk about the down cell. We talk about the Hull cell. So all these ones will fall under what we call the industrial processes. The next item that's also tested in paper 2 is about salts. Salts comes in terms of what we call the salt analysis, where it is part of the practical work that is being used in the theory, where you're supposed to know everything that touches on qualitative analysis, test for those metals that are taught under those the topic on metals. Remember, whenever you're doing the KCSE, you add something, then you talk about something soluble in excess. Now, when it comes to theory, they want you to tell us what is this substance that is in excess, and write the complex ion. So in this case, there are 5 complex ions that you are going to study. So those ones are some of the areas that are tested in paper 2. So hand it over to Mbaluka to continue.
Okay, thank you. Just to, of course, continue doing surgical analysis on these and also bringing out the importance of these topics and the analysis that we have done. Are you looking at this with students? We have a very abnormal student here who is just writing things here. No, let me check. Enoch, can you check if you can disable the annotations? Let me try to disable them.
Okay, let me see how to do that.
Yeah. Oh yeah, need to disable annotation for others. We also need to clear. Yeah, okay, yeah. Oh, super. Oh, good. So we okay, Enoch? We are okay. We can be able to continue from there. This one has to go faster. So just one thing that is very much important, we are doing this because of the students who might think they are very weak. First of all, look at that paper 2. Paper 2, about 70% of paper 2 is mostly from forward. So paper 2 is from forward because there are likely 2 questions that are going to come from there from 1 to 3. That's always periodicity and also now the industrial chemistry. Another thing that is very much important, remember that there are those students, and I know there are those students who are always asking, which method will be tested? Let me tell you. As you can be able to see, the extraction of metals and non-metals fall under industrial chemistry. So you treat metals just like another topic, like sulfur, like carbon and its compounds, like nitrogen and its compounds. The same way, the 5 topics under industrial chemistry under industrial, there are normally 5 topics. So this year we may have carbon, next year we may have a metal. We may have, so a metal is not a mass, but sometimes you find a metal and a non-metal being tested. So it's not a must to see sodium. Of course, the last metal that were tested are the sodium, copper, and aluminum. I'm not saying they are the ones that are going to be tested, but those are the last ones that were lastly tested. Number 2, also don't focus on the prediction. In 2020 and 2021? 2020 and 2021, they tested sulfur. They repeated it because the when sulfur was tested first, I think in 2021, it was very difficult. So most of the students failed. So they repeated it the following year. So the setting of the KCSE also depends on how the students performed. Yes. So it is very much. Number 2, look at physical chemistry, rate, radioactivity, energy, and electrochem. Topic ni hine. But nasema maswali ngapi? 2 or 3. Normally there are 3, by the way. Normally the topic that is rarely tested is radioactivity there. So you can imagine, do you know that these topics are also going to feature in paper 1, the 4 of them? Now, electrochemistry we'll still have the electrolysis in form 2 and electrochemistry in form 4. So we have the electrolysis and we have the electrochemical cell, whereby now each of them is tested. So electrochemistry normally asks 2 questions. So we are having 15 marks from that physical chemistry in paper 1. Then in paper 2, you get like food, if there are 3 questions. Then in paper 3 again, you're going to find energy changes. So again, you find this topic alone, you may end up having about 70 questions, 70 marks, or even 60. Industrial chemistry, topic ni 5, pia kutakuwa na 15 marks paper 1. Periodic table, ujue inakuanga na marks kama 9 to 12, 9 to 12 in paper 1. Because remember, there are so many topics that are synchronized in periodicity. The atomic structure and periodic table, chemical family, structured bonding, and the trade across. Although trade and cross nowadays, they are synchronizing it with chemical families and structured bonding. But you find you're going to get about almost 10 marks. So periodic table will sometimes carry almost up to 25 marks. So can you focus? Paper 2 topics, make sure that umeiva vizuri kwa sawa kabisa. That's it. Are we together, students? Are we together?
Yes.
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 Paper
Yeah.
two, paper,
Yes.
paper two. Good, good, good. I can see you're following. You're very magnetic. You are very sparkling and magnetic. Somebody please to mute those students. If I muted you. Now, our physical chemistry, we have in question 1. Question 1 is tested from the physical chem, that is in paper 3, and that is titration. Then we have energy changes, rate, solubility, and cooling curve. So the titration is almost a constant factor. So titration is a combination of energy changes. Titration can be combined with rate. Titration can be combined with solubility. Titration can be combined with cooling curve. The chances of getting rate and the cooling curve this year is almost 0. So I'm not saying as the Kuja, but likely you may find titration energy and titration solubility. Those are likely changes. Question 2 is test for cations and anions. And question 3 is organic qualitative test for the functional group. Look at what I'm talking about. In paper question 3, you're talking about test for the functional groups. I'll give you notes for this. The question 2 and 3, you only need 3 pages. And you're going to be through with whatever can be tested in KCSE. Are we together, students? Are you ready to get those smart notes with which I'm likely going to share by the end of as we continue with this presentation?
Yes.
Yes.
Yes. So,
Yes.
Yes. Yes.
good,
Yes.
boys and girls. You're very magnetic. Of course, they're doing very well. So question 2 and 3 can be interchanged. That means I say question 2 can be organic and question 3 can be inorganic. So you just need to know the reagent. That's the most important thing. Question 1 is usually mixed concept between titration and changes, solubility or rate. That's the thing. Sasa acha tuingie kwa content. Kuna vitu nazitanga delimitators. Delimitators inamaanisha, using the superior powers that I have as a board member of IUPAC and being the certified working chemical and the ocean of chemistry, I have the powers to coin some terminologies that are only found under UPAC. So delimitators means the D and the E eliminator topics. The amount of these are delimitators, D and the E eliminators. So the D and E eliminators are like the periodic table, which can give you about to 25 marks, salts 10 to 25 marks, industrial chemistry and gases almost up to 40 marks. Physical chemistry inaendanga 50 to 80 marks. Hizo topic ziko hapo. Umesikia kuna topic lazima zitokee paper 1 15 marks. Paper 2 zinaweza enda up to 40. Paper 3 lazima ukuwe na physical chemistry. Organic 30 marks. You already, the way Mr. Mbuguswa told you, kutakuwa na organic 1, organic 2. Already kutakuwa na maswali 2 kwa paper 1. Then kutakuwa na swali lingine kwa paper 2. Na organic lazima ikuje paper 3 again. Now you see. So focus on those topics hata kama maisha ni ngumu. Kama wewe ni poor conductor, focus on those ones. Now, what can we observe from that analysis of the KCSE exam setting? Form 4 is king. If you are weak, focus on paper 2 and paper 3 because the same topic that are tested in paper 2, they must also feature in paper 1. Focus on topics that are likely to give you more marks. Avoid over-reliance on past papers. I know some of you now. Those who have my number, I don't know how they got it. They always on my inbox. Mwalimu, please give us the alliance exam. Those who have, somebody might even travel from Kakamega or Kitale to go to Sabaot to go and borrow papers for Kenya High or Alliance Girls, Kapsabet, because you think they are the ones that are leading. So don't focus. Don't have what you call over-reliance on past papers. Question revision methodology is obsolete, archaic, and fossilized. And normally for the sharp students. Kuna wale watoto wamesoma vitabu mpaka wanashindwa nini tunasoma. So they only revise using questions because they want to look at. Kuna swali moja inakaa inaweza nishinda. So that's exactly what bright kids are. But now, I'll tell you how. Mastery of content is key to quality grades. And this is where we are now. Append your two core. Revise your notes. They are irreplaceable. Students, are you getting that main point?
Yes.
Yes.
Yes. What was your
Yes.
nataka karatasi ya Alliance High School? If I give you the papers for Alliance High School, Alliance Girls, Kenya High, Kapsabet, Maseno, Maranda, Mang, Mary Hill, Loreto, whatever, how many will you be able to revise? I'm telling you, my sons and daughters, that you're going to revise 20 papers and still find nothing in the KCSE. But there's no way you'll get your notes. I'll show you the undisputed octopus technique. Hakuna vile utachukua. Like now, for example, if I want to revise water and hydrogen, I only need 6 minutes to revise that topic. Now, there's nothing that can get out of that. Tukisema hapa tuna revise water and hydrogen, tunaanza na the sources. Ukienda kwa mtihani kwa kitabu yako, sources of water, kuna natural chemical sources. Hakuna examiner atai kuambia name 3 sources of water, anza kusema rain water, lakes, rivers, ocean. Leave those nonsense to geography students. The chemistry, we are going to focus on the chemical sources of water. And how do you obtain water? By burning an organic compound or by burning hydrogen. Burning an organic compound is not what you are taught in Form 1, only a tendo. It can be biogas, it can be even, you can even prepare methane and you burn, you're going to get water and carbon dioxide. You can burn methanol, ethanol, any of that. When you look at that setup, vile iko kwa kitabu, you'll pass it over sodium, calcium hydroxide to test for carbon dioxide. Then you're going to pass it over maybe ice cold water, whereby the water vapor now condenses to liquid. So you are going to be, all questions will revolve around that. What the test for that liquid that is formed there, what observation is meant in the tube containing calcium hydroxide, write the equation for the observation that you have observed above. That's exactly what can be tested from there. From there, you go to the chemical properties of water. How does water react with metals? Water only reacts with, cold water only reacts with group 1 and group 2. That is probably sodium, potassium. Hizo ndio zinaulizwa. Hakuna mtu atakuuliza how francium, radium, rubidium react with water. But of course, we are going to do the prediction using the chemical families, whereby somebody tells you there is this element with an imaginary name that is below potassium. Then you are going to predict how it's going to react with water. That is relating the activity. So only sodium, potassium, then calcium. Then you need to know what are the observations. For sodium, potassium, the metal will float on the surface of water, will dart on the surface of water, will melt into a silvery ball. The reducing solution will change red litmus paper blue, because the resulting solution is alkaline. Cold water and a metal, you get metal hydroxide plus hydrogen gas. That's the point. So you know those kind of things. From there, you go for sodium. Sodium will sink. Why? Because it's denser than air. The other metal, group 1, will float because they are less denser than air. It melts into a silvery ball for group 1 because the reaction is highly exothermic and those kind of things. Then you go for steam. Steam, you revise the concept of how does zinc, aluminum, and iron react with steam. Metal plus steam is equal to metal oxide and hydrogen. Then you collect the hydrogen through by downward displacement of water. Then from there you go preparation of hydrogen. How do you prepare hydrogen? Dilute HCl plus zinc. Then you collect the gas over water again. Then you're going, if it requires dry, you collect it over by using or rather upward delivery, rather by downward displacement of air. Then there'll be those questions. Why we cannot prepare hydrogen using copper? Because what? Copper is below hydrogen, the reactivity series, therefore cannot displace hydrogen from a dilute acid. You'll also be told why we don't use nitric 5 acid, because nitric 5 acid is a strong oxidizing agent, will oxidize the hydrogen produced to water. Then they're also going to ask you why we don't use sodium and potassium, because they are highly reactive and they may lead to an explosion. Why we don't use lead and sulfuric or lead and hydrochloric, because there will be formation of insoluble lead sulfate or lead chloride, which will coat the surface of the metal, preventing further reaction. Then you go to the chemical properties of hydrogen. There are only two: burning hydrogen in air and the hydrogen as a reducing agent, whereby it's going to reduce lead oxide and copper oxide. Then you can go for uses of hydrogen. Nini ingine inaweza testiwa hapo? Student, are you listening to what I'm talking about?
Yes.
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 Oh.
That is
Yes.
called
Yes.
exam mapping. How many minutes have I spent? Wewe unashinda tu pale ukisoma mambo ya how magnesium react with steam. Then examiner analeta iron. Unaambiwa, how does iron react with steam? What are the observations? Many students will say a brown solid is formed, which is wrong. Iron when react with steam, what do you get? You get triiron tetraoxide, which is black, and hydrogen gas. So when you revise it in the octopus way, you become very much prepared. So revise, go and group yourself, mujipange vizuri, ambia rafiki yako wewe to summarize high water and hydrogen, mwingine carbon. I'll also show you how to go about it. Let's look at now the revision strategies. Hii kitu inakuonyesha vile nimeanalyze mtihani from 1995 to 2023. And I'm showing you vile the total marks that have been generated from the Form 1 for those years. From 1995 to 2023, Form 1 imetupia 399 marks. From 2, 824. From 3, that 1,346. And from 4, 3,398. Let me ask you, what are you saying from there? Form 4 peke yake, you got more marks than the other classes. Mr. Mbuguswa can tell you that the theory analysis, the one that you Form 4 alone generated how many marks?
It was 66.
66.
Out of paper 1 and paper 2.
One out of 160, 66 was for work. Then you go to paper 3. Paper 3 is only titration part. You concept ingine inahitaji the knowledge of Form 4. And there was only 10 marks from titration. So you find the other 30 is going there, 96 marks for Form 4 work. So can you measure that you understand the Form 4 work? Students. Naelewana, eh?
Yes.
Msingoje 3 days to the exam.
Yes.
You need the exam, then you're being given this information. Kama una enda usome hizo topic. Umeambiwa already electrochemistry lazima itokee. Wewe enda sasa uanze kusoma organic, lazima utokee. Tafuta mwalimu huko nyumbani hata akufunze. Haya, KCSE focus revision strategies. Mnatumianga nini? Sasa tuende kwa real now. The pragmatic approach. Anything else opposed to this is dogmatism. You know, when you are dogmatic, you are not, your reasoning is not based on logic. So we are looking at the pragmatic approach, the practical. So content-based revision ndio tunaangalia sasa. Hiyo ndio kitu moja. Kwanza nataka kueleza content-based revision ni nini. Mna revise na nini? Ama ni kuja kuchukua nani yako na moga ya kwanza kuja. Mnapitia hata revise, hata mmeandika maswali mbaya bado hamuoni kitu. October revision model. And examination content mapping. Yo, Mr. Mbuguswa atawafanyia. Now, this content-based revision sample for chlorine. Look. Mnaona?
Very
Yes.
clearly.
Okay, now,
Yes, tunaona.
if not, I'm going to reshare. I'm going to share in my Twitter handle. Because maybe, of course, I cannot give my number to all the students, and I may not be able even to respond to all your queries. But I'll be able to post this one in my Twitter handle. If you have a question, you can also ask it there. You can tag me at Thaddeus Mbaluka, or rather at Macau Thaddeus. I'll be able to see that. So that if you tag me there, because I cannot give you my WhatsApp number, rather my number, I'll not be able even to say it because I love so many messages. But when you tag me there, even the teachers, you know, when you send me that, somebody may even ask it, answer it from my page. Even other teachers are here, they can be able to answer that. Mr. Karane, are you here? Mr. Karani. Yeah, yuko hapa. Mr. Lando Kambianga, I saw you. Are you here? Anyway, it's okay. Now we are looking at.
Mbaluka, I'm around.
Oh, ulikuwa umelala? Okay. Karibu sana.
No. I'm around.
How is the
Fully around.
Okay, good.
Kabianga is fine.
Yes, I'm just saying that so that if these students are able to post to tag me, check my Twitter handle so that we can be able to handle any issues that are coming from there. Now we are looking at this.
It's okay.
The other time I did nilifanya hii chlorine. I don't know whether you want me to do it, but I want to do something else because I already did it for chlorine. But let me just give you an example. Now, first of all, this is a revision model for somebody who is through with the syllabus. You cannot have 10 books na uko na mtihani sasa tuseme KCSE iko kesho paper 1 na uko hapo na KLB paper 1, uko na Med Familia, uko na the Octopus, uko na Top Notch book 1, uko na Top Notch book 4. You'll be looking like a mad person. You'll be looking like a chokora who is collecting trash from all the villages to read. The more you are looking at those books, the more you get scared. These are the kind of notes you have. With this kind of notes, you like this chlorine and this compound. I've summarized it in one page. It's only because of presentation. I'm doing it nimeikatanisha for purposes of presentation. Tunaelewana, eh?
Yes.
So let me show you example.
Yes, Bwana Mbaluka, it's good. You are doing good work.
Yes,
Okay.
you're seeing.
So we are able to see that here we have preparation. Instead of writing 3 diagrams on preparation of chlorine, you come here. What are the reagents? You require potassium manganese 7, manganese 4 oxide, lead 4 oxide. All of them, we are using concentrated hydrochloric acid. With manganese 4 and lead 4, we heat because they are weaker oxidizing agents. Then we pass it through water, water removes HCl. Then we pass it through conc sulfuric acid. The conc sulfuric acid is used to dry the gas. Then the gas is collected by downward delivery. Then how do you test for the chlorine gas? You insert a moist blue litmus paper. It changes to red, then it is bleached. Now, I understand students by looking at that octopus diagram, that summary, ushajua mahali popote kuna solid, the solid iko kwa flask, and the liquid iko kwa nini? The liquid iko kwa distilled funnel. Are we agree? Are you understanding that?
Yes.
Then they
Yes.
are
Yes.
asked the role of potassium
Yes.
manganese,
Yes,
manganese oxide, the role
you
of
are
it to
quite well, Bwana Mbaluka.
yeah.
Iko sawa. Iko sawa, Bwana Mbaluka.
Okay, karibu. So now I'm saying, then they are going to ask what the role of manganese oxide, lead oxide is to oxidize the hydrochloric acid to chlorine gas. The role of it, and of course, this question normally asked. You remember this question about the HCl in water and the HCl in methyl benzene. Then you asked what observation is meant when you add in water and HCl methylbenzene and you add potassium manganese. So many students will just say there will be no observation because HCl in methylbenzene is polar, in water is polar, then they'll double. Then the real answer is in methylbenzene, HCl does not dissociate, exist as a molecular, and therefore does not ionize. But in water, the HCl ionizes to form chloride ions, which are oxidized by potassium manganese 7 form chlorine gas. That's why you see bubbles of a green gas. That's the key word. Role of it, increase the rate of reaction and also prevent formation of the insoluble N2 chloride. I think some students might also have asked themselves, how are we able to prepare chlorine? Tukitumia, how are we able to prepare chlorine using lead and hydrochloric acid, and lead chloride is insoluble in water? They are reheating. In presence of it, you cannot form the insoluble N2 chloride. And I want Mr. Mbuguswa to explain why we still pass it over water. The chlorine and the water, why chlorine and HCl, all of them do not dissolve. So, Mbuguswa, you can navigate through.
Okay. Now, this is the preparation of the chlorine. We've seen the 3 oxidizing agents. That's potassium manganese 7, manganese 4 oxide, and lead 4 oxide. They're all being reacted by sulfuric acid. Now, the two reagents, that is MnO2 and PbO2, require that you heat. But after you've prepared the two gases, if you want it to be dry, you must pass the gas through what is called water. Sometimes students will ask that water may also dissolve chlorine. Now, what happens if you pass water and yet you collect on the other side? I want you to know this, that chlorine gas, when it gets to the water, it mixes with it to form hydrochloric acid. And whatever is going to pass through is not passing through water, is passing through HCl, so that reduces the chances of it getting to the other side where it is going to be dried. Then sometimes you also need to collect a dry gas. There are three main drying agents. There is what you call concentrated sulfuric 6 acid, the calcium oxide, and hydrous calcium chloride. Anytime they ever ask you which gas cannot be dried by a particular reagent, remember calcium oxide as a drying agent will never dry gases that are acidic. Those gases. So that's why we can use concentrated sulfuric 6 acid. We can also use the other one, which is anhydrous calcium chloride, to dry that particular gas. Then this gas, there is we look at the special properties of some of the gases. Like now this chlorine, there is one of the reagents that it does that it bleaches. Then the other one is called SO2. One of the similarities is that for the two to bleach, we need water, because hydrochloric acid will only bleach because HOCl has been formed, and the other one also be SO3. So we need water. So there's a difference in the way they bleach. One of them bleaches by oxidation and the other one bleaches by reduction. What you can see on that screen is a setup to show how chlorine bleaches. Now, whenever you're writing the dye, don't write HCl plus dye. The dye must always appear on the right-hand side so that that plus or the minus will always be on the other side where you have done the bleaching property. Sometimes they'll ask you what observation is made if we are using dry chlorine. Yes, if you're using dry chlorine, then just know one thing is that that bleaching may not take place because the H or Cl has not been formed. Then below it, you're also looking at the reaction between halogen and this compound, that is the chlorine, with these metals. And one of the most interesting way is using iron or aluminium. That aluminium will always react with the chlorine to form what we call AlCl3. Now it's important to know something about this Al. One, AlCl3 is a covalent compound, but in vapor, when it's in vapor, it sublimes. It sublimes or it dimerizes to form Al2CL3. There are cases where you may be asked to draw the dot and cross diagram for the bonding in aluminium 3 chloride. We don't draw for AlCl3, but you draw the one for Al2Cl6, which I think you're going to see it later on, how it is supposed to be drawn whenever that happens. Then everything is about sublimes. Why does it sublime? Is because it has a simple molecular structure that requires little energy for it to be collected on the other side.
There's Asan Mugure, you have raised your hand. Can you bring up your question? Asan Mugure. The floor is yours. Unmute yourself and ask a question. Ama tu ameinua tu mikono bila kujua anauliza nini. I think you are there. Look hapa.
Teacher,
Yeah, yes.
I was asking.
Yeah.
For tunasemanga for nini the chemical test, because ulisemanga state the observation made when a blue litmus paper is inverted into a chlorine with the water. which has been exposed which has been exposed to the sunlight for 42 hours.
Yeah. So you're asking the question?
Yes, state the observation made.
So you need to know that or rather chlorine breaches only in the presence of sunlight. So on any exposure to sunlight, even for 1 hour, already the chloric 1 acid will be converted to HCl. So if the chlorine water is not fresh, that's why we are saying for chlorine water to bleach, it must be fresh. So if it has been exposed to sun even for 2 hours, then and you insert a red litmus paper, the red litmus paper remains red, or rather is not bleached, because the chloric 1 acid in presence of sunlight will already be converted to chloric acid, and the chloric 1 acid is the one responsible for bleaching. But if it is the blue will turn to red, will change to red, but it will not be bleached. Reason because it changes to red because already the solution is acidic, but will not be bleached because the chemical chloric 1 acid that causes bleaching has already been converted to hydrochloric acid. That is the question. And the answer is still here. And as you're going to be able to see, in as much as this is a summarized 1 page, it is very pregnant. It is impregnated with a lot of information that summarizes everything that you need. Looking at what Mr. Mbuguswa was taking you through. But metal, how chlorine react with metals. Look at the diagram. Now, this one is showing you the diagram. If like, for example, you're preparing, unaona ile chlorine umepitisha pale, ndio hiyo chlorine, na pale kuna combustion tube pale, tuseme hiyo ni combustion tube. So if this is the combustion tube, for copper chloride, magnesium, or any other metal that does not sublime will remain in the combustion tube. But now, if it is aluminum chloride or iron chloride, you need a receiver. You know the receiver, this one now.
Yes.
Yeah, sasa hii uta collect kwa receiver. You know, the information that is there, all of it, hapa kuna heat. Hapa kuna heat, na hapa kuna chlorine ikikuja. So we are saying, kama hapa umepitisha magnesium, copper itabaki hapa. Kama ni iron na aluminium itakuja hapa kwa receiver. You need to understand that concept. Excess chlorine is passed through the guard tube containing calcium oxide, or rather, if there is unreacted chlorine, or rather excess chlorine will also be passed through a guard tube containing calcium oxide, or passed through sodium hydroxide or potassium hydroxide. Like, for example, if you are now preparing something like magnesium chloride. So now for non-metals, phosphorus, hydrogen, ammonia, silicon, iodine, hydrogen sulfide, they also react with the chlorine to form this. And now if it is ammonium chloride, it will also be collected by, many students. An example will tell you, I could pitishie chlorine, no, see chlorine, sorry. Ataleta nini mbili. Ataleta tube mbili sasa pale kwa combustion tube. Hii side moja na hii ingine. Sasa side moja, si venye sasa unajua you cannot put ammonia in the combustion tube. So there'll be 2 tubes. Side moja inatokea, sorry. This thing is very sensitive. Side moja inatokea ammonia. Side moja inatokea ammonia, ile ingine inatokea chlorine. So then they are going to be formed in the receiver, but there must be heat. That where they are mixing, there must be heat to generate that kind of a reaction. So that kind of a ammonium chloride, and that ammonium chloride now will be formed in the receiver. That's the point. So then how does it react with sodium hydroxide? Cold dilute, kila kitu imeonyeshwa pale. Hot concentrated, kila kitu imeonyeshwa pale. So now I'm not going to go through all of it. Mnaona hii pia inaendelea chlorine, cold dilute, displacement reaction, what you get. Kama ni reacting with bromine, kwa ile notes zako ongeza, I'll give you more notes. Kama ni chlorine per potassium bromide, you'll get an orange ama yellow solution will be formed. And by the way, I want to show you this. I know many students are wondering. Now, when you are now talking about displacement, this chlorine is a gas, is reacting the ionic equation, with bromide ions aqueous, And also the bromine, which is formed here, is also aqueous. And I think you're wondering why it is not canceling each other. There will be a student who is asking that. Do you have a student who is asking that? Because you are told aqueous solution, they ionize. So you expect this one to be bromide ion to cancel each other. So let me explain. This is bromide ions, but this is bromine molecule, which is not, it is in aqueous state because bromine molecule is aqueous, but it's not ionized because it's existing in the molecular state. But now these are bromide ions because they are already ionic, derived from an ionic compound, potassium bromide. This is bromine molecule, which is dissolving in water, but it is still aqueous, but it is in molecular state. Therefore, it's not ionized. Let that one think. Then you're going to be talking about observation, colorless to orange, to yellow. With iodine, colorless to we talk about brown solution or a black solid is posted. Then how does it react with iron 2? Green solution changes to yellow because iron 2 is oxidized to iron 3. So you can be able to see all those things, including the preparation of the sulfur 4 sulfite changes into what? Because somebody can tell you sodium sulfite, you added dilunitic acid. Then there were bubbles. But the same, another portion of sodium sulfite, you added chlorine, then followed by dilute acid. There'll be no bubbles because the sulfite will be converted to sulfate. Then you're given the uses of chlorine, hydrogen chloride, kila kitu imepeana pale. How do you prepare it? Just the same thing. The uses of hydrogen chloride gas. Then we are also giving you the hydrochloric acid, how the large-scale manufacture, the raw materials, the main reaction that occurs in the burners, and their adsorption. Then you're going to say to prevent an explosion, a controlled amount of hydrogen gas through a jet is ignited in excess. So you can be able to see these are sample of a summary. And I want to believe you have already taken a screenshot, students, right?
Yes.
Can you mute that person who is not normal? I am Makwagweta official.
Yes, I have a question. May you kindly clarify on the color change when chlorine gas is added in the potassium bromide and potassium iodide solutions kindly?
Okay, very good. When you bubble chlorine through potassium bromide, you simply displace the bromide ion to form bromine water, not bromine liquid. So what is the color of bromine water? It's yellow. But of course, we also accept orange. So the solution, the bromide ions are colorless. So in potassium bromide, we're having the bromide ions which are not colored. But the bromine solution, which is now displaced and in solution, is all yellow in color. So the colorless solution changes to yellow. When you add the bromine, again, iodide ions are also colorless. So the colorless solution changes to brown because iodine, this is what happens. As the iodide ions are being converted to iodine, in the initial stages, the dilute stages, the iodide ions will appear as a brown solution. But as time goes by, then now the iodide ions, they solidify to form iodine, which now appears as a black solid. So the examiner will mark both brown solution formed or a black solid is deposited. Is that correct?
Mm.
Yeah, so those are the issues of concern. So that is the way you can be able to see with this kind of notes. Can you be able to read them in 10 minutes?
Yes.
Yeah.
Yes. Is it helping you? Does it make sense? You know, when you revise these notes like that, you're going to spend less time, and there's no way exam will come out of the note. Exam is there from the syllabus. So that is now the undisputed octopus technique. So if it is in at the Peter Zote, can I take you through the others? You just take a screenshot, then you can use it for revision.
Yes.
Yes.
Yes, Mwalimu.
Yeah, there's something additional.
Yes.
Okay. Listen, there's something being added here. Let's Mr. Mbuguswa add
This is
something.
about the chlorine and these compounds. if you look at the KCSE that was set last year, KCSE 2023, I want to observe that there was no single question that came from chlorine and its compounds, right from the chlorine and even the one that we ever did. So some of those are also parameters to assist us to know how much are we supposed to revise on this particular topic. So, the whole of the chlorine and its compounds was never tested.
Yes, Mwalimu.
The revision of this, it's also important to take on this. What is most important about this chlorine and its compounds that there are usually 4 important areas. Number 1 is the large-scale manufacture of the HCl, which is an industrial process. Number 2 is the setup for preparation of HCl. And another one is the preparation of chlorine. One of these things that comes in the exam, you may simply be asked to draw a setup that can be used to prepare any of those particular gases. So as you also look at it, get to know about how the setup looks like and the reagents required. And sometimes whenever it comes to the exam, like in the preparation of HCl, one of the reagents normally is called rock salt. It's called rock salt. They don't write the formula for that. They simply tell it's rock salt, and then you're asked write an equation. So please go ahead to know what exactly is the chemical name for rock salt for you to be able to do that. Then in the preparation of HCl, we are using concentrated sulfuric acid. And whenever you're writing that particular equation, like rock salt, which is NaCl plus sulfuric acid, you don't form sodium sulfate. Instead, you form sodium hydrogen sulfate. Because for that sodium sulfate to be formed, you need a lot of heat, which may not be provided under the ideal conditions for that particular experiment. And there is a property of that HCl, which is called low volatility, that makes it to be generated from that. And then when you go back slightly, there was that particular setup where you are reacting HCl through iron. The first thing we always start with, how do you test, how do you dry chlorine? The next thing, there is the setup. And then on that guard tube, there is what you call the calcium oxide or anhydrous calcium chloride. Sometimes they go ahead to ask you, why do you prefer to use calcium oxide and not anhydrous calcium chloride? Both of them can be drying agents. It's because the calcium oxide can absorb excess of the chlorine and also remove that moisture. It prevents the oxygen from coming in. It also prevents the other one from, it dries the mixture, that setup there. So you need to know. Sometimes they also draw for you that particular setup, but there is a condition that is missing. So one of the conditions is you check that there must be heat available. Or they can also ask you some of the precautions you can also carry it out in what you call the fume chamber. Then the last one is about the reaction between chlorine and sodium hydroxide. It many times comes in the exam. What do you get when you use dilute and what do you get when you use concentrated? Note how they are written. For dilute, you get NaOCl, but the other one you get NaCl2. The other products are exactly the same. It is only that compound that changes. So many times whenever they ask you in the exam, watakuuliza, write an equation for whatever you get whenever sodium hydroxide is reacting with chlorine. Check, is it hot or is it cold? It's okay. But NaOCl and NaCl2 all have the same uses. They can be used as what you call bleaching agents. So other than using the HOCl to bleach, I can also use this one to do what? Bleach. And the way you write the other one is also the same way you're going to write for this one. However, NaClO3 is also called a weed killer. So sometimes that is also the use. It's called a weed killer, NaClO3. But if I am now reacting chlorine with calcium hydroxide, I exactly get the same thing, but now that substance that you get when you use calcium hydroxide is called a bleaching agent. It's not a bleaching agent, it's usually called the one that you use for bleaching. So, yes, wanakuuliza, what is the role of this compound that you get whenever sodium hydroxide reacts with calcium hydroxide? So that one is actually the one that you use for bleaching. So as you read about these chlorine and these compounds, those are some of the important aspects that you're supposed to know in as far as this one is concerned.
Yeah, so it's about from the boiling of the of chemistry itself. You'll also be able to write down any additional that we are also going to upload in the Twitter and
bleaching powder. Yes.
So now that's it. So we go to that's the extraction of metals. You can take a screenshot, but I'll give you the most comprehensive. So this is the extraction of metals in one page, but nimeikatanisha kwa sababu ya presentation. Mnaelewa student eh?
Yes.
Niwapitishe kila kitu hapa so ujue tu. Yeah? Kuna swali Hassan Migur.
Excuse me, teacher.
Yeah?
Teacher kidogo.
Yeah.
Sodium chlorate 5 and sodium chloride have different solubilities in water. Name a method that can be used to separate the salt.
Fractional crystallization. Two soluble salts. they can only be separated using fractional crystallization because they have different solubility than they are soluble. That's the point. Umeshika? That's the way. So have you taken a screenshot?
Yes.
Not yet.
Hii nimewaandikia na mkono kuonyesha possible. Msione kama unajua mkiandikiwa vitu na when they are typed you think they are very unique, ni kama kuna ghost imetoka from hell. No, these things are possible. But of course this one you can only get this one from the UPA command center. You're not going to get it anywhere. Are you saying it's possible to summarize the entire metals in one page? Are you saying it?
Yes, sir.
And we expect you to have the diagram, like Ajua, how to label the cell for extraction of aluminum. Like this one is a very common thing. And Mr. Mbuguswa will always say that when we tell students, name an ore of sodium, they'll remember rock salt. But when you tell them, now name other two, maisha inakuwa ngumu. So always remember at least 3 or maybe a minimum of 2. All because the examiner will ask you apart from this, name another O of this. Another common mistake is the balancing, but you don't need to balance the electrons, just write them the way they are. The other common mistake is this. When the student are taught to label the electrolyte, wanasema molten sodium chloride, that is wrong. The electrolyte is a mixture of molten sodium chloride and molten calcium chloride. The same with in extraction of aluminum. The electrolyte is not molten aluminum oxide. It's a mixture of molten aluminum oxide and molten chloride. Tunaelewana?
Yes.
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 Okay, yeah, because now, realistically, if you use molten chloride, the cell will not work as expected because now it will require that high temperature. That's not what is used. So make sure that you are able to get that. So everything is captured there, but now I want to show you a one page. Mnaiona sasa?
Yeah, it's being seen.
Well, now you take a screenshot. That's one page that I've already analyzed using. We have already analyzed with the with Mr. Enoch is here. Is the one in charge of design in Top Notch. So he's the one who I may come up with the idea about organization and the everything is.
Please zoom in kidogo.
Oh yeah, that is it's good, bwana Mbaluka.
Zoom in.
Yeah, there's something that I need to just add here. Like there's a way there's always the question on describe. Describe the test for cations. So you can see I've summarized it. For all the 6 metals, I've summarized it in a head of a page. So for all the metals, you always start with crush the ore into a fine powder. And then add dilute nitric oxide. This one, this method of the first statement, when you're told describe a rocky material suspected to contain aluminum, a rocky material suspected to contain copper. For all of those ones, the starting point is crush the rock or the ore into a fine powder, add dilute nitric acid, stir, and then you filter. Then now you use the filtrate. For aluminium, you require 3 filtrates, 3 portions of the filtrate. You divide the filtrate into 3. First one, add sodium hydroxide. Second portion, add aqueous ammonia. Third one, you can add sodium chloride, sodium sulfate, or even potassium chloride. In fact, for aluminium, when they bring it, there is one mark for crush the ore, add dilute acid, star, filter, about 1.5 marks. Then there is now, I have a mark for add sodium hydroxide, I have a mark for add aqueous ammonia, I have a mark for adding a chloride. So you don't have to explain what is observed. Then with the lead, you just add either sodium hydroxide or aqueous ammonia. Ukiongeza sodium hydroxide, you get white PPT soluble. Hiyo ni ZAP. Ukiongeza aqueous ammonia, unapata white PPT insoluble. Hiyo ni Pamela. So when you have ZAP, you can simply eliminate lead by adding potassium iodide or any soluble chloride or soluble sulfate. For this one, you get a white PPT. For potassium iodide, you get a yellow PPT. Any other thing confirmed absence of that. For extraction of zinc, or rather testing for zinc, iron, and copper, you only require 1 portion, and you can add aqueous ammonia. For copper, blue PPT, soluble in excess to form a deep blue solution. For zinc, white PPT, soluble in excess. Iron, green or brown PPT, insoluble in excess. Does it make your work easy?
Very magnetic.
Yes.
Mwalimu, thank you.
Yes.
For sodium, you just crush the ore and you add water because those sodium salts are soluble. So you only add water and filter, stir and filter to remove the undissolved impurities. Then you can use a flame test to confirm presence of sodium. Then float flotation, usishinde ukijipea pressure. Float flotation will apply for the 3 metals that contain sulfur. And that is zinc, lead, and copper. Kila kitu imeandikwa hapo. So I'll not take you through everything like that. I'm just here to summarize your work, to make your work easier by giving you the notes so that you can screenshot and you use them to revise. Alafu, usikae tu hivyo kama ngunia. Don't be a certified, lazy, and fossilized ngunia who is not ready to do anything. When now you have these notes, please, can you go sit down and write them? Hata unaweza zipitia, then you try to write them. Don't be lazy. Can you be magnetic? Can you exhibit characteristics of a certified working chemical, rather a protege of the ocean of chemistry? Can you, if I am a teacher, I'm not waiting for an exam, and I'm sitting down for you and summarize these things like that, you can imagine how much time I'm able to get like that. You are the student. So don't just keep them like that. Can you sit down, read, and try even to summarize without copying my thing? Then after that, you can compare what you have copied with what is there. Then you try to modify it until you're able to capture it. Are we understanding, students?
Yes.
Hata hiyo chlorine, please enda ujiandikie. Mbuguswa, anything to add?
Just want to add something.
Yeah, the part of
on
sodium is
metals.
not. Part ya sodium haiko clear.
Kwa nini haiko clear? Let me see if I can zoom. Yeah, let me see. Let me change so that I can. Kama kuna kitu haiko clear, I'll zoom. I'll take you through zooming. Now mnaona?
Yes.
Iko sawa?
Yeah.
Can I change this one so that in case somebody wanted to zoom the other side, you unaweza zoom side ya aluminium? Nawekea hivi so that mnaweza zoom kila metal kipekee yake. Sawa, iko sawa? Pande ya testing umezoom? I taken a screenshot. The one for self-preparation, have you done the screen? Sawa?
Yes.
This one, you done it? Uko sawa sasa?
Uko sawa mwalimu.
Perfect. Now continue being magnetic and do the, yeah.
So there was something that I wanted to add.
Mr. Mbuguswa, I wanted to add something and also mention on the pollution effect.
Something on the metals, which is going to be a summary whenever it comes to reading. Now, these metals that we've covered, they can be divided into 3 groups. Number 1, we have all those metals that are extracted by electrolysis, that is the aluminium and the sodium. The way you read aluminium is the same way you're going to read about the sodium. And these are the things. Number 1, in the extraction of aluminium, you use what you call the Hals cell. But in the extraction of sodium, you use what you call the down cell. They draw for you the cell, they ask you to give the names. Number 2, in the down cell, all the anodes are found in the middle, while the cathodes are found on the sides. Even in the extraction of aluminium, all the anodes are those electrodes that dip into the electrolyte, and the cathodes are also on the sides. Whenever they ask you to label the anode, you label that particular electrode that is dipping in the electrolyte. Number 2, in the extraction of aluminium, you add cryolite. But in the extraction of sodium, you also add calcium chloride. Those are the only 2 metals where you add something. The reason for adding cryolite and the reason for adding calcium chloride is the same, to lower the melting point. When it comes to this exam, please go ahead to tell us the temperature change. For example, in the sodium, to lower the melting point from 800 to 600, the other one is 2015 to around 800. The reason why you're lowering the melting point is exactly the same. In the 2 cases, there is a precaution required. In the down cell, there's the use of the C diaphragm to prevent the sodium and the chlorine from recombining. Please don't say to prevent it from combining because they're already combined, so it is recombining. But in the other one, we must constantly replace the anode because at the high temperature, the oxygen combines with the oxygen to form CO2. That calls for replacement. Now, during the extraction of sodium, we add sodium, the cryolite. Now you may be asked, how comes it is only sodium, it is only aluminium and not sodium being discharged? One, of course, is about the high concentration of the chlorine that favors the other one not to be produced. And even in the extraction of sodium, we have added calcium chloride. You'll also be asked, why is calcium not also being discharged? It's because the other one has a higher overpotential. There is something in chemistry which is called overpotential, which prevents the other one from being discharged. And then also in the extraction of aluminium and sodium, you notice that aluminium is usually tapped at the bottom because it's denser than the electrolyte, but sodium is tapped at the top because it's less denser than the electrolyte. We are using the same concept to explain the ease of the discharge of the 2. Then when you go to the extraction...
the way Mr. Mbuguswa is saying, remember those students, when they are told like why the sodium, like for example, the way it may be formed at the top, they say it is less dense than the sodium chloride, which is now wrong because the sodium chloride is not the electrolyte. The electrolyte is now the mixture of the 2.
Yes.
So that's the point.
You talk about the electrolyte.
That's the market point.
Then again, in the extraction of aluminium and sodium, you also notice there are only 2 substances. There is a metal and an non-metal, which you are going to say later on. Then next on, you look at what you call the reduction. The reduction, there is the iron, there is the zinc, and there is that is the zinc, lead, and iron.
Yes.
I want you to know this. For you to revise those 3, you carry out the process which is which uses a cell. It's called the blast furnace. Whenever you are extracting zinc, one of the ores that is present, the zinc ore, is called galena. So galena can also be extracted the same way you extract the zinc. Because when you roast this one, the galena is also roasted. When you get oxide, the galena also gets an oxide. You reduce, the other one also becomes reduced. So when I'm extracting zinc, I'm also extracting lead. Now, whenever you get the lead, you know that the working temperature is lower than maybe the one for zinc. You find that zinc goes up and then lead goes down. So by doing so, you have already extracted the zinc and the lead at the same time. And then now you are left with the copper, whose process is slightly different because you must first of all obtain the copper oxide, become copper, then you do what you call the electrolysis. Now, all these processes, anytime it comes to the exam, you are going to be asked about what is the environmental effect of the extraction of these metals. In all of them, there is what we call the formation of gullies, amaranth degradation, because they are all extracted from the ground. That one becomes one of the effects of extraction of the cell. However, we also have others which can also lead to pollution. Even sodium, even during the extraction of sodium, there is production of chlorine, which can also lead to pollution. Where there is SO2, it can also lead to pollution. Wherever there is CO, they can also lead to pollution because it can also cause global warming. So you need to know effects of all these on the atmosphere whenever they are extracted. And then lastly, many times whenever you get questions on metals, like for example, sodium and aluminum, it can also extend to Faraday's law of electrolysis, where you've done the extraction of metal, but towards the end, want to release how much of this one has been formed. Look at those equations that you've been given there on the screen. Aluminium is aluminium, 3 plus 2 electrons give you aluminium. So when it comes to the calculation of how much aluminium has been formed, you only use 3. Don't use the 12. It is only 3 that will give you 1 more, which is 27, to give you that. So whenever we do the balancing, don't use the plural balancing to do the calculation of how much aluminium has been formed. Now, come on oxygen, it always remains 4. Whether it's STP or RTP, you use 4. To discharge 1 mole of oxygen, you need 4 times 500. So those are the equations. So whenever you've been asked, write an equation for a particular one, write that one. Like, you know, please write the equation for the anode and the cathode at the same time, you must always do the balancing. But when it comes to the calculation, you only use the singular one to do that particular calculation.
Thank you, Mr. Mbuguswa, for that. That's the circular wisdom. By now, yes.
When you're being write the formula of the cryolite.
Yeah.
What is it?
That one is already in your books. Huh? That is not, of course, the sodium chloride is what?
Na3, Na3, then ya mwisho ni 6. Ya mwisho ni 6. Na katikati ni
chloride.
It is sodium, aluminum, phosphate. It is Na3, alafu ya mwisho inaisha na 6. That is the formula. It's always there.
Yeah, just take your books and information. Yes?
A question?
Yeah?
In zinc, how are the impurities removed? In zinc.
What you're saying the zinc
in the extraction of zinc, how are the impurities removed?
In extraction of zinc, the impurities, remember, in this we have the flow flotation. In the flow flotation, that's whereby the purpose of flow flotation is to increase the concentration of the O and also remove the what?
Impurities.
Impurities. That's how you increase the concentration. Look at that. Crush the O into a fine powder and add it to, of course, a container containing the following. Hot air, we blow in hot air. Then we have the water and we have oil. So then now, we talk about the water is to dissolve the inorganic earthly impurities. The hot air will create a froth, rather the oil, or the oil, the one that dissolves now the holes. So in that kind of a scenario, you remember the O will be formed on the top. So the gas, or rather the undissolved impurities now go at the bottom. So the removal of impurities and zinc is also zinc and lead and copper is also removed under flow flotation, because the purpose of flow flotation is to increase the concentration or rather the percentage of the O. And then also remove impurities, because the impurities are also removed, that kind of a thing.
And sometimes they always ask you, what is the role of the water, what's the role of the oil? You can always just put it in simple terms. The role of the water is to sink earthly impurities, meaning water will have dissolved the ones that are hydrophilic. When they dissolve hydrophilic, whatever has not dissolved sinks. That to sink.
Yeah.
Then once you put the oil, it also dissolves now impurities that could not have dissolved in water. But in the process of oil dissolving the impurity that would not have dissolved in water, it surrounds the ore. And because oil is less denser, it makes the ore to start rising. And then when you blow air, it increases what you call the buoyancy between the ore, and it makes it to move up where it can be skimmed off. So those are normally what is called the froth flotation. So that the whole thing is called froth flotation. When it comes to the surface, it is acting like it's a froth, but it is floating on top, and it can be removed from that. Usually we use the formula for chloride is Na3, Al, and F6. So that is the formula.
Mwalimu,
Huh?
you said that overpotential is one of the reasons why sodium is the one that is being produced.
Yeah.
So is overpotential the same as standard electrode potential?
You know, in simple terms, like calcium is higher than sodium in the electrochemical series. And being higher, it means that the metals, the cations lower in the electrochemical series are always preferentially discharged. Are you getting the point? That what I'm saying? That is the simplest way to talk about the factors that determine which cation is preferentially discharged. Look at the electrochemical series. So which one comes first? Which one is higher, calcium or sodium?
Sodium.
No, no. You are confusing the reactivity series with the electrochemical series. With the reactivity series, after potassium, it is sodium, then calcium. But with the electrochemical series, which determines which cations are preferentially discharged, it is calcium that comes before sodium. Kijana, umeelewa?
Yes.
So
not.
overpotential simply means
Yes.
I have two things. I have a sodium and I have a calcium. Because of the overpotential, it means that the sodium will be discharged instead of this one. Just like whenever we do the diaphragm cell, you have a diaphragm which only allows a particular thing to get in, but the other one can never get out. That is called overpotential. Ni kama kwa physics, you talk about inaitwanga nini? Short circuiting. I have a fuse and a switch. If you pass electricity, the electricity is going to pass through a fuse and not a switch. In that case, we say the switch has been over something like that. So preventing something from being discharged. Yeah. However, we may not go into detail to teach you about the overpotential because not in the syllabus, but that is how you're supposed to mention whenever it comes to the exam.
So students, the way we are saying, ile kitu tumezoea ni position of the ion, the electrochemical cell. Just simply say sodium. Wale amuelewe hiyo concept ya Mbuguswa ya potential, mnaweza sema tu sodium is below calcium in the electrochemical series, and therefore it is preferentially or rather selectively discharged. Are we together?
Yes.
And
Yes.
don't confuse reactivity series with electrochemical series. With the reactivity series, we start with sodium, potassium, sodium, potassium, followed by sodium, followed by calcium. But in the electrochemical series, we start with potassium, followed by calcium, then sodium is lower than calcium in the ECS. Get that one right. Sawa?
Potassium.
Yes.
Okay, perfect. Very quick. Can you take screenshot of the summary of carbon? I will not talk about this because of time. Vile Mbuguswa amwambia, unajua last year it was carbon. In 2022 and 2021 it was sulfur. So likely the non-metals are likely going to be tested nowadays are mostly nitrogen or chlorine. Hatuseme ndio zitakuja, we are just giving the last year it was the even paper 2 was the solvay. So can you go to the next one? Have you taken a screenshot?
Yes.
Yeah. Sure.
Yes.
Excuse me, on the calculation involving the Faraday's law,
So if it's about electrochemistry, we'll get a day we tackle it. So please, can you keep your questions? I get another day for that.
See,
but I can answer if it's something that can easily be answered. Just ask. Calculation of Faraday's law. Can somebody mute this student? Unmute yourself, Hassan.
So,
screenshot.
I was asking. I was asking. In the calculations involving the Faraday's law, the N for oxygen, it is 4. To save all gases is 2.
Atipo?
For all gases, we put N equals to 2. Yes.
For what?
What for other gases?
No, you see, the only gas that you're going to be discharging and electrolysis is only chlorine and oxygen and hydrogen. So just know that except oxygen will be 4, or any other gas it will be 2. Because we are never going to discharge a monoatomic gas. We are not going to discharge argon. So come away in the book, just know these are the same things that you can easily, in fact, if for example somebody tells you, watoto lazima mjue hata kuguess, hata kama uko poa aje. Ukiambiwa compare the atomic radius of Q and R, there are only 2 options. Q has a larger atomic radius or Q has a smaller. Sometimes just put something there and wait for God to help you. So even you can even get something. So of course, for gases, except unless the gas being discharged at the cathode or the anode is, the anode is, the gas being discharged, the anode is oxygen. Any other gas, the N will be 2. That is now the number of electrons required will be 2. I know for those people who are using the formulas to do calculation.
So for that one, we can just summarize like this. Whenever it comes to calculations on Faraday's law, 1, you need to know that oxygen will always be 4. Aluminium, 3. Copper, zinc, and chlorine will be 2. Sodium will be 1. Na kuna ingine utaipata kwa mtihani. And we talk about oxygen is 4.
Mr. Mbuguswa, can you repeat? Because I think they are not getting
we are saying this, These are the areas, 1, oxygen will always be 4. Whether it is electrolysis of bauxite, whether it is electrolysis of bauxite or whatever it is always 4.
Aqueous or
it is 4. Aluminium is 3. Copper, hydrogen, chlorine is 2. Sodium is 1. But sometimes they also go to silver, which is not being taught here, but it can also be 1. And then it ends there. That is what happens.
Are we okay?
Thank you. Yes.
So electrolysis, you can be able to see all those kind of things. These are things that are automatic. And of course, these are comprehensive things. We have already done it. Ion is sulfur. Octopus for sulfur, the most comprehensive. Look at it. Take a screenshot. Maana hii kitu imekusamarizia kila kitu. Kama ni first process iko na 3 pipes. Outermost, innermost, middle pipe. Na kila kitu imepewa role yake ni nini? Everything. Mambo ya sulfur oxide, how do you prepare it? What are the observations? How do you collect the solution of it? The sulfur 6 oxide is here. And of course, just explain to them this one, the sulfur oxide. That is something they don't know. Why sulfur oxide is collected as a solid crystals and not as a liquid or a gas.
Okay. So remember, in chemistry, you've learned about 18 gases. There are those ones that are prepared using liquids. Others are prepared using gases, solids, and others are prepared using gaseous state. And the one that's prepared using gaseous state is called SO3. You also remember that SO3 has a very high affinity for water. And that is why during the preparation of sulfuric acid, we take SO3, dissolve in water to give us oleum. Now, in the preparation of SO3 in the laboratory, which we normally talk about theoretical because you may not be able to do it, you need SO2 and oxygen. These two must be passed through platinized asbestos or vanadium 5 oxide. We get SO3. But the SO3 in the laboratory is collected in crystalline form. Now, they may ask you, why can you get SO3 as a gas? The reason is because SO3 can easily absorb water and change to something else. But now, when this SO3 is collected as a gas, it means that we have brought the particles of the gaseous molecule very close to each other. And because the particles of the water have come closer to each other, it means that we are not paving way for water to get in. And that means that we reduce the chances of SO3 absorbing the water to vaporize to become sulfuric acid. So look at the difference between solids, liquids, and gases. When something is a gas, it means the particles have been brought together. Therefore, we minimize the chances of it absorbing the water. And that is why it is collected as a gaseous state.
So just for purposes of screenshotting and for those who have eye issues, so can you let's go step by step. Let's screenshot that part. You done the overall, but I'm very sure that kuna watu wengine hawaoni, so I'm trying to make it bigger. Tunaelewana student, eh?
Yes.
Yes.
Screenshot
Yes.
part ingine?
Yes.
Yes.
Mara ya pili, haya tuteremke. I'm sure you had now screenshot that. You'll combine the two. So, then this one. Contact process. We only have about how many steps? About 5. Burner, reaction, it occurs in the burner, purification chamber. Then we have the drying tower, we have the compressor, the heat exchanger, catalytic chamber, absorption chamber, na kuna hii. Watu wajui scrubber, they always ignore it. The reaction, the scrubber is very important. Tuko sawa? Of course,
Yes.
Yes.
Oxide is not dissolved directly into water because the reaction is exothermic and leads to formation of harmful acid fumes. So everything is being captured in those kind of things, the raw material, the conditions, and all those kind of things. So that's all. Now, we are almost breaking up because we are also getting tired. That is summary of industrial manufacture of sulfuric acid. The summarized one, you can be able to get on it. Of course, those are summarized in the previous one, but of course, in case you want it more summarized, is of course given the it's summarized in that concept. Of course, pollution control, we can have the flow device. That is now the FGD. That's a fuel gas, the fuel desulfurization. We are removing the sulfur, the flue gas desulfurization, and waste gas into the effect.
And as you look at this particular process, there is also something that we also need to advise. We have checked on how the recent exams are being set, is that they are setting questions that are not very unique to us. You notice something about sulfuric acid, they normally write 98% Cong. When you go to sulfuric acid, they write 65% Cong. We never know this time, they may ask you what is the meaning of 98%. And I'm sure most of us are going to fail. 98% means that out of the sulfuric acid that you got, 98% of that is actually sulfuric acid. Only 2% is water. That is why it is very viscous. Because sulfuric acid is obtained as 95% 5%. Sometimes you'll be asked, how do you increase the concentration? We can pass the nitric acid through sulfuric acid to absorb some of the water so that you increase the concentration. That's the meaning of 98% conc. In case you got it somewhere, in books we have never taught you about that, but it can come anywhere. So there is a time they ask, why is it called the contact? You know, many people failed. You know, the same is the name of a scientist.
You can give them that answer because none of students.
Oh, why is it called the contact process? The process is called the contact because the production of SO3 or SO2 and oxygen comes in contact with the surface of a catalyst. That is the word contact. The production of SO3 happens whenever SO2 and oxygen comes in contact with the catalyst.
About simply that the reactants are in contact with the catalyst.
Yes, but the reactants is SO2 and oxygen.
Please repeat.
It is called the contact process because production of by the way, SO3 is the main gas here. Production of SO3 occurs whenever SO2 and oxygen reacts in contact with the catalyst. Those two, SO2 and SO3, for them to react, they must be in contact with the catalyst. If there is no catalyst, then nothing is going to happen. That is the reason. The other way, you have also been asked, during the production of ammonia, why do you compress nitrogen and hydrogen? If you read some papers, they simply tell you to forward the equilibrium to the right. But why do you have to compress the two? We must compress the two because in order to bring the hydrogen and nitrogen together for effective collision, which is called that collision frequency, that they must be together in order to increase the successive collision so that the equilibrium shifts to the right. That's how you write it.
Okay. We'll continue from there.
Can you please pardon Mwalimu?
About
the 95% conc.
Oh, 95% means, 98% means that out of the sulfuric acid that has been produced through the contact process, to say even if you have 1 liter, 98% of that mass is concentrated sulfuric acid, but only 2% is called water. Out of the 100, 98% is concentrated sulfuric acid. So there is only 2% which is supposed to be water. And no wonder, whenever you're writing concentrated sulfuric acid, you normally write there H2SO4, and then down there you put liquid. So liquid means much of that is molecular. If you take sodium, you put in sulfuric acid, do you expect it to react?
No.
Sodium, weka kwa sulfuric acid, will it react?
No.
It will not react. That sulfuric acid is highly unsaturated. No wonder we normally add water to ionize for it to start reacting. And how do you concentrate, how do you dilute acid? Do you add water to the acid or you add acid to water?
You add the acid to water.
Acid to water. Good. Even there's a time they've been asked to describe how you can be able to dilute an acid. Because sulfuric acid requires water. So if the sulfuric acid is in the water down, then you add water, it will jump up to trap the water. Instead of jumping up, it now splash. So you're supposed to add now water to the acid so that it sucks as it gets
the acid to the water.
Yes, that's how you do it.
Then, Mwalimu, how about concentrating it? If, for example, it is 65%, you are asked to concentrate it.
Good. What you do, the first thing is you oxidize. That's one. You oxidize 65%. Remember, during the preparation of sulfuric acid, you normally get something called HNO3 and HNO2. So when I concentrate, I oxidize that. The other reason to increase is you pass the acid through concentrated sulfuric acid. So when you pass the concentrated sulfuric acid, it absorbs some of the water that is within the 65 so that the solution goes up. So those are the two ways of concentrating the sulfuric acid.
Then
lastly, there are two
Thank you.
methods that we have ever taught you in chemistry that can undergo dimerization. One is aluminium 3 and another one is NO2. NO2 is brown, but when it dimerizes, it becomes N2O4, which is yellow. Sometimes they can tell you, give a reason why the sulfuric acid weighs this one and it's not supposed to be like this one. Talk about whether it undergone something called a dimer. So, dimer means it multiplies into 2. But where it multiplies into 3 or 4, it is not called a dimer, it is called a polymer. So, if it becomes 3, 4, it's a polymer. If it becomes 2, it's called dimer. So, those are the areas where we have taught you about dimer and polymer.
Okay, I think because of time factor, the preparation of gas is done in the online. We have done it. The Mbuguswa have done it. I've also done it. So if you look at the top-notch channel TV for the summary of the gases, we have done this one because of the time factor. Or we'll be able to continue from there. These are summary of qualitative analysis. I'll allow students to screenshot. That's a summary of qualitative. When you talk about question 3, this is the only thing that can be tested. Hakuna kitu ingine. Na ujua hapa hakuna, there is no elimination method. It's just cramming. Whatever can be tested, question 3 is only this one. Current potassium permanganate, there's only one thing. They have acidified potassium manganate 7 changing to colorless, double bond, triple bond, ROH present. The purple acidified potassium manganate 7 is not decolorable, remains purple, double bond, triple bond, ROH absent. Then remember that you can burn a solid, burn the yellow sooty flame, and a double bond, triple bond present. The same solid you dissolve in water, then you add potassium manganate 7, does not change to purple. Then you write double bond, triple bond, ROH absent. Uko sawa. So there is no contradiction here. So just make sure that kazi yako ni kucramp and don't bother. Even if you start with dichromate and does not change from orange to green, utaandika ROH absent. If in the next test you add potassium manganate 7 and change it from purple to colorless, utaandika double bond, triple bond, ROH present. Even if you have said they are absent in the previous one. So there is no, every test in organic chemistry is independent. And the reason for this is that even some of the things will deviate from what your teachers are teaching you, or rather from the books, the way the books are saying. Because the books, when you read the book, they'll tell you all organic acids are weak acids. That statement is only referring to the syllabus we teach. Not all the acids that are going to be brought in KCSE is what we teach in the KLB. Because the KLB, you are only learning methanoic to decanoic. Those are straight chain monocarboxylic acid. They are straight chains and they are monocarboxylic acid. Then in the chemistry, KCSE, some of the acids the examiner will bring are aromatic and aliphatic metacarboxylic acid, meaning that they may have benzene ring like benzoic acid. Ukiangalia lab utapata benzoic, utapata maleic, utapata oxalic. Those are the common acids in your lab. Maleic and oxalic, they are metacarboxylic. They are dicarboxylic. They are more than 2 carboxylic group, and therefore they are strongly acidic. So ukipata pH1 usiende kurefer note, enda ufanye practical vile inafaa kufanywa na ujibu chenye kiko. There is also some changes nowadays whereby we used to test the pH only for the organic, but nowadays we are even testing for the inorganic. So make sure that you are able to understand that. This is the only thing that can be tested. Hii ndio ile tunaitanga octopath question model. In a summary of organic, all the reaction and all the processes. These things I've done them in the YouTube. Please can you go and read. This one is found in Octopus revision question kitabu ya Octopus at page 200 and around 270, 269, depending on which edition that you have. This is where you're going to get all the questions. Whatever can be tested. Kama examiner KCSE wataileta swali ya organic flowchart, it will be a portion of this. Number two, they may also change, instead of starting with ethanol, they put with propanol, propanol to propane, propanol to propanoic acid. Just make sure that you're able to get that. So that's the most important for you. Try to get that. I think most of you have the Octopus book. It's also available at the market. You can be able to get that. And because of time factor, we'll be able to continue from there. The other topics that we have not done. So I like to get some time so that we're able to look at them. So we want to stop at that point, and in case a student has an issue, please, if you have enjoyed the session, you can write a presentation, a message on the comment section, and you also tell us maybe the school or where you have been following the session from. Thank you so much. And we'll have to stop at that point because of a time. We are also getting a little bit drained. We need to go and get some supper. With me, I've been with Mr. Mbuguswa here. We'll schedule another session, whereby we are going to continue magnetizing you. Do you want another session? Of course, just tell us what you need. The topics you want us to unmask, rather you need us to demystify, because this is the UPA command center.
Whereby to unwrap energy changes very much.
Yeah, there's no problem. I'll be able to navigate to that. Mr. Mbuguswa will give him the electrochemistry. We'll come and package it here. You can see now with me there, Mr. Mbuguswa, and of course, when you're here, you're able to circle all the wisdom in the entire world. This is the UPA command center, whereby all the wisdom flows effortlessly, or rather, the wisdom, everything about chemistry, it flows effortlessly in our nerves and our blood veins. Of course, it is simply flowing, rather diffusing, or rather without any energy that is needed. So we love you so much. This is me giving back to the community by providing information for those students who we may never meet. I go through so many schools. I may not be able to go through all the schools. So therefore, for those students we will never meet, we wish you the best, but of course I'll be able to get other topic. I think electrochemistry and maybe thermochemistry, if you're asking, we'll be able to sit down and we'll give you a date. We'll also be giving you, the link will also be the same, you can be able to see. The time will also be the same, we'll be able to announce. So make sure that you continue checking up. In the YouTube, we'll also do an advert so that we tell you when you're having that. We'll also distribute the same through that. So look at the top notch on my TV, you'll be able to get much of the content from there. And thank you so much. May God bless you, and may God inspire you to be able to understand all the information that you're going to provide. May you become more hygroscopic than a fluorescent. May you become more hygroscopic to the wisdom, so that you can be able to absorb it as much as possible. May you become more thirsty for wisdom, like sulfur 6 oxide is for water. So, Mr. Mbuguswa, maybe you can say one word.
Yeah, so just want to thank you for coming. Also sparing your time, shows that you have a level of interest, because whenever we invite you to come, if you do not come, then this program cannot happen. So that shows that you are willing, and as we give you your best, and we expect you to also give us the best your end. Remember, what you are doing is you already the syllabus, so as you are only there to see how much you need to expect as you prepare for this particular examination. So thank you.
Thank you, Mr. Mbaluka and Mr. Martin.
Thank you, teachers. We are very deeply grateful for your work.
Okay, welcome, and all the best. We love you.
Thank you, Mwalimu.
In our life. Asante sana.
Thank you, Mr.
Bye. Okay.